Okay, so here we go. Let's look at our first problem. Okay, we have y equals 9 minus x squared. So 9 minus x squared is an inverted parabola that has a height shifted up 9 units. Can someone tell me what this x-intercept would be? 3. How about the one way over here? Negative 3. Okay? The next thing is x is equal to 0. That's the y-axis. Then we have y is equal to 0. That's the x-axis. And we want to find the shaded region that is bounded between these functions that we just drew. Don't overthink this. The shaded region that's bounded, because it gave us 3, will end up becoming this region right here. Because if it was between the red and the purple, they wouldn't have given us x equals 0. They would have just given us the 9 minus x squared and y is equal to 0. If they were talking about all of the area to contemplate. But what they gave us, they're asking us to take this cross-section area and to rotate it about the x-axis. Okay? So this is going to come out of the page and rotate like our visual example that we had, and it's going to rotate like this around the x-axis. Rotate and rotate to create vertical slices. And I'm trying to help you with all the steps.
You just drew the extra rotations that were outside the parabola to show
that the whole piece, yeah, just to show the direction. Okay? Vertical slices means what?
dx.
dx.
And if it's rotating about the x-axis, does that automatically mean vertical slices and about the y-axis horizontal slices?
Yes.
Yeah.
Any rotation about a vertical axis is automatically dy. Any rotation about a horizontal axis is automatically dx.
You couldn't do it that
You couldn't do it the other way around. Okay? Alright, so here we go. You have two choices. Visualize this, and I know I don't have this nice little slider that will show this popping out right now, but if I did, would it be a disc or washer method? It would be disc. Why would it be disc?
because the area, there's no gaps.
There's no gaps between this rotation of this axis of rotation and this shaded region. All shaded region is touching, hugging, kissing, whatever, the axis of rotation. No gaps. So disc method. Pi r squared.
This method will always be pi r squared.
Yes, and then washer will always be pi big R squared minus little r squared.
So we're not, if it gives us a shape that it's making.
Well, those are cross sections.
Oh, so that's. Oh,
There you
okay.
go. That's the difference, guys. What we did the last couple of days, at least last time, were cross sections that it gave us those area formulas. Here, when we revolve or rotate, they're always these shapes of cross sections.
Gotcha. I was wondering on the website where they kept getting that
Yeah.
r squared from.
Because when you spin it, right, it's just creating these circles.
Yeah, the volume one.
Okay?
That is fine.
What's my low to high? What's my low x to my high x? 0 to 3. Remember, this is all revolving. This is all surrounding the shaded region. Okay? Now all I need to do is find something that represents r. This right here will represent the length of the radius. With me? If I rotate it about the x-axis, is this the length of a radius? Yes or no?
Yes.
Yeah, that's the length of a radius. Because I'm rotating it around the x-axis. So it's like, when I rotate it, you don't have to draw this, but it would create this mirror image. And you have this going on down here as well. I'll do it a different shade of gray. Okay? And this right here would be the radius also down here. Because each cross section is going to be a what? What's the shape of each cross section? A circle, a disc. A disc that's rotating about the x-axis. So the way we started today's activity with that Wolfram demonstrations thing, it's one of those slices. Do you see the radius now? Okay, here we go. If I asked you to tell me the length of this green radius, well, you would see these endpoints right here at the x-axis and here where it touches the red graph, 9 minus x squared. I just have to come up with the length of that. And I'm going to come up with this length simply by saying top minus bottom. So what's the top?
9 minus x squared.
Minus the bottom. 0. If I simplified it from here, it would be 0 to 3, 9 minus x squared, quantity squared. I can't do u substitution because there's no 2x anywhere. So this would FOIL out to this if it was without a calculator. And then it would be 81x minus x cubed over 3, and then x to the 5th over 5, evaluated from 0 to 3, and whatever you get, multiply by pi at the end. Units cubed. Yeah.
Wait, how did you integrate that?
Just what's the integral of 81? 81x. Then it's,
Okay, never mind. Yeah, you integrate, or like you fold it out and then.
yep. We good? Yeah.
It's like on this one, this c would be 0. Right?
There's no c. Remember, when you have a definite integral, you don't have c's. That's only if there are no bounds, if there are no limits of integration.
Oh, my bad.
No, you're good. Any questions, guys? Yes?
It's probably another weird question, but will there ever be a time where the axis of revolution is not just a straight line up or down?
So, yes. So that's multivariable calculus, where you have like z-axis and almost like polar. Like it could revolve around three-dimensional kind of space out, not just a two-dimensional axis, vertical or horizontal. You see what I'm saying?
Yeah.
Again, you will not learn that this year, nowhere close to that, but in real application, yeah, it goes there too. And the reason why, I don't know if I mentioned it last time, let's say that, so here is u, yeah, u,
Oh, I thought
and we want to, let's say, we want to strike gold, right? And we ended up drilling, and we found this huge barnett shell underneath, way down here. And underneath all of this rock, and I'm talking about thousands of feet under ground level, we hit a barnett shell of natural gas. So let's say that we have all of this is rock, right? And they have those, it almost feels and sounds, it looks like bat sonar, if you will, where you can put a device on the ground and shoot like vibrations, sound vibrations, and then it will bounce back to show you how far below did it hit something, or was something no longer existing per se? Like, kind of similar to like seismographs with earthquakes and whatnot. And let's say like way down here, you were able to find, and you dug, and you were able to find, oh, around here is whenever the ground, the dense ground kind of stops. And even further, way down here, it started back up again. So now, with that kind of technology, thousands of feet below the ground, you know that there's natural gas all there. And you wanted to find the volume of that natural gas. This is kind of what you're doing. So that if you're going to spend about this much money to drill down, where you could get maybe, I don't know, this much money of profit, you would know whether it's worth drilling because of the volume of natural gas. This is just one example of how you can use this kind of stuff.
How would you spin this one?
Okay, so it's this. So you don't necessarily have to spin this one. What you could do is just find the area, kind of like between here and here, and just multiply it by what is that depthness or height to it to kind of give it that volume. You see what I'm saying?
Yeah.
But these are approximations. These are good approximations. Not necessarily exact per se, because the integrity of the ground could have been a little bit different than what you thought modeled would be. Cool? Petroleum engineers use this kind of stuff all the time. And many former students are not petroleum engineers. Any questions? Okay, so now let's change it up because it gets pretty involved pretty fast. I'm going to go to this example here. We still have this 9 minus x squared going on. We still have x is equal to 0 going on. And we still have y is equal to 0 going on. Because our shaded region is still, in fact, whoops, this region right here. But now, I want to revolve it about y equals -2. So here is -2. Whoops. All right, I'm going to call on you here in just a bit. Please be ready. So here's the x-axis. Here's the y-axis. And now we're going to revolve this shaded region around y equals -2. Are those vertical or horizontal slices? Still vertical, right? So we're going to go ahead and still put what? dx. Okay. Disc or washer? Washer, because you see the gap that is created right there. You see it? That gap is going to have a hole in that three-dimensional figure. Okay? So let's go ahead and put this as washer method. Big pi r squared minus little pi r squared. So we GCF'd out that pi. So it's just big R squared minus little r squared. What are my bounds? Still 0 to 3. Now here we go. Let's use, I'll use black for this first one. From the axis of rotation all the way to the outermost piece of this area with a vertical line, what is the top? 9 minus x squared. Minus the bottom. Here we go. From the axis of revolution, we're going to go up to where the smaller radius would stop. It's going to stop at the end of that void. What's that function? y equals 0. So top minus bottom, there's big. Oh, my bad. I kind of did them both at the same time. But it's 9 minus x squared minus, whoops, I made a mistake. That's why you guys were kind of looking like, what's going on right now? Let's go back to this big black line. Okay, big R. The top function on big R, you guys were right, is 9 minus x squared. What's the bottom function of big R? -2. Okay, let's do the green, little r. What's the top function on little green? That's y equals 0. Minus the bottom function on little green, -2. Which some of you are already seen. It's just adding 2, because you're subtracting that negative. We good? So this 9 plus 4, you could say, is the same as 13 minus x squared, minus 4 squared, and then kind of just go from there.
Oh, you can combine it before.
Yeah, because it's in PEMDAS, right? It's the same as adding it to that 9. Oh, my bad. I don't know why I put 13. God, I'm doing all this other stuff and I can't even add. So 9 plus 2. You know what I was thinking? The 2 squared. Nice catch, Christian. We good?
So shouldn't that one be 2 as well?
Yes, nice job. See? Nicely done. Good? Alright. And yeah, you don't have a 2x for u substitution, so you'd FOIL that out. 121 minus 22x squared plus x to the 4th. Then you just would subtract 4 and do it all by hand. Questions? Alright, so we're going to do 2 more, now at a faster pace. Now let's see if you can see it without necessarily having to draw too much information. Here we go. And I keep doing this because I want you to see what are the steps so that you know how to write them out. Here we go. So 9 minus x squared, x equals 0, y equals 0. The shaded region bounded is here. And this time we're going to revolve it about the y-axis. Okay? What do I do, guys? Help me out. How do I start? Okay, so are these vertical slices or horizontal slices? Horizontal. So, dy. Perfect. I concur. Yeah. It's horizontal because as you rotate around, you're creating horizontal circles. So, like, imagine your cylinder way back when things were easier, right? If you revolved about a vertical axis, this is like stacking a bunch of these circles just on top of each other. So there's one circle. Let's see if it will allow me to do it. Maybe not. Let's see if it'll let me do it this way. So there's one circle as the base. Yep, it will. And then there's another, right? And then there's another. And then there's another. You see what I'm doing? And then ultimately it's creating this volume of stacked circles. And because it's an axis of revolution about a vertical axis like this, these are horizontal slices. Okay? Nicely done, guys. Okay, so what now is my next step now that I...
Find the bound for x.
So we could do the bounds. We could do the bounds.
We gotta know that it's the disc.
We got to know whether it's the disk or the washer method. Disk, because there's no void. That shaded area is touching the axis of revolution the entire time. Here we go. Pi, oops, r squared. Because of this, one of these equations that I use, guess what variable I'm going to have to solve for? Solve for y.
Which it's already in.
My bad, my bad, my bad.
Oh,
I
yeah,
see what
yeah,
you're saying.
okay.
Solve for x by itself. X equals something because all of this y stuff, which means in terms of y, is going to go here. Somewhere. Okay? So we have y equals negative x squared plus 9, which is x squared equals 9 minus y. So x is the square root of 9 minus y. That is this length right there. Which is the what of every single one of these circles? The radius, which is radius squared. You with me? So we have pi r squared.
Do we have to do the minus 0?
We don't have to do, well, you can if you want. Yeah, that might as well. It's just to be consistent with what we've been doing, right? Because the thing is that the 0, you're like, I don't need it. But when it's something other than 0, like your next one, you might not be as fluid to get it easily. Okay, so the top is the red by turning, okay, so this is when we turn our head, right? Just for the top minus bottom. The top function is this minus the bottom function. What's the bottom function?
Just
X equals 0. Now, do I turn my head 90 degrees to get the bounds? No, I look at it straight up. What's the lowest y of that shaded region? 0. What's the highest y? 9. And this would get you the volume of that rotation. Easy stuff? Good. Alright, so now I'm going to be a little bit lazy. What I'm going to do is, this time instead of revolving about the y-axis, I'm going to revolve about x is equal to a negative 2. Okay? So let's go all the way back to about right there. So x equals negative 2. Yes or no? No.
Wait, can you say that again?
X equals negative 2. Is this a good approximation for that? So it's got to be to the right of that x-intercept, right? So x equals negative 2 is about right here somewhere. And we're going to rotate it kind of like that. Kind of looks like one of the very first things that we showed with those visual examples. All right. What do I have? Washer for sure. Yep. So it's big R squared minus little r squared. What else? Say again?
Pi.
Times pi, yep. It's dy because they're horizontal slices. So that I know, because it's dy, I got to get everything in terms of x equals. And again, we already know what this is because we solved it before. It's just going to be the square root of what? Yeah. So, here we go. From the axis of rotation, it's the best way to do it is from the axis of rotation. Jump on the axis and go to the outer rim. The furthest outer piece and stop. Rotate your head, and what do I write as the top function? Square root of 9 minus y. Minus, look at that black line segment. What's the bottom function? Negative 2. So now, let's go back, and with the green, we're going to go from the axis of revolution, but we're only going to go to where the void ends so that we can create the smaller arc. Turn your head. What's the smaller arc? 0. What's the, what's the top of the smaller arc? You said 0. And what's the bottom of the smaller arc? -2. Alright, and that's what we have. We just have to now write down the bounds, right? And what are the bounds? 0 to 9. Nice job, guys. Not bad, right? If you had just black and white, this could be a nightmare to see. If we didn't see those visuals at the beginning, this could be a nightmare to see. I think you guys have enough experience in practice. Are there any questions?